Section 2 starts talking about polynomials and their factors and zeros. All stuff we've discussed in the previous chapter, but we'll kind of put a new spin on it. So we're going to talk about zeros of a function. Remember from chapter 4, the zeros of a function are also called the x-intercepts. And because it's an x-intercept, that means that that's where the function crosses the x-axis. That's the definition of an x-intercept. So think about it. Every time you're on the x-axis, even though the x value changes, the y value is the same. It's 0. So we're going to write these x-intercepts, these zeros, these roots, as an ordered pair where the y value is 0. So we already did questions like this in the beginning of the second half of chapter 4 and chapter 4b, but we're going to put them as ordered pairs today. So it's not new at all. Remember, when the factor is x minus 9, the root is positive 9. Well, today we're going to write that as an ordered pair, 9, 0. And the same thing with x plus 3. As an ordered pair is negative 3, 0. Number 2, remember when there is a GCF out front that has a variable, it gives you a root of 0. So 0, 0. And when there's a coefficient in front of the x, it becomes a fraction. Opposite sign still, constant over coefficient. So this root will be a positive 1/2. And then the last one is 4, 0. Number 3, the x plus 4 factor gives me negative 4, 0. The x minus 3 factor gives me 3, 0. And the 3x plus 5 gives me a negative 5/3, 0. Opposite sign, constant over coefficient. Shouldn't feel too new. It is what we did in chapter 4. Pause the video to complete the U-triads. So here it's going to be just like we did before, where if it's not factored, you have to factor it first. So when you look at number 1, there is a GCF. Pull that x out first. Leaves you with x squared minus 4x plus 4. Factor that further. Two numbers that multiply to 4 and add to negative 4 are negative 2 and negative 2. I'm going to write it as minus 2 squared. So my roots, as ordered pairs, are 0, 0 because of the GCF out front, and 2, 0 with a multiplicity of 2. Remember that squared in the air tells me that we have multiplicity, or twins. Number 2 is already factored for you, so I'm going to go right into the roots. The root here is negative 3, 0. But because of the 3 in the air, we have a multiplicity of 3. Number 3, I see a GCF of x here, so I'm going to start by taking that out. If I pull an x out, I'm left with 2x squared plus x minus 1. Be careful with that minus 1 on the end. But to factor that further, this is one of those guess and check ones that I'm sure you loved so much from chapter 4. I know that it has to start with a 2x and an x, and the only factors of 1 are 1 and 1, so that helps. In order to get a positive x, this middle term right here, in order to add to a positive x, I need a plus here and a minus there. Remember to check the O and I in FOIL if you have a hard time factoring those. So my roots are 0, 0 because of the GCF, positive 1/2, 0 because of the 2x minus 1, and negative 1, 0 because of the last factor. Remember, the number of roots will always match your degree. This is a cubic. Cubics have to have 3 roots. Pause the video to do the U-triads. The factor theorem. The factor theorem says if you have a factor of a polynomial, it gives you a 0 of the polynomial function. And that goes backwards, which means if you have a 0 of a polynomial function, you can get a factor from that. So you're going to notice that the second half of this lesson goes backwards. They're going to give you the zeros, the roots, the x-intercepts, and they want you to give them a polynomial in standard form. So first thing I'm going to do is make factors from each of the zeros. My first 0 is a minus 2. That means the factor was x plus 2. And then this positive 2 means my factor was x minus 2. And this positive 3 means my factor was x minus 3. Remember, it's opposite. All I need to do now is put it in standard form. Standard form means no parentheses, combined like terms, all that fun stuff. I'll tell you, your best bet is to always do opposite factors if they exist, because if you FOIL them, things cancel for you. I'll actually do this in a different color. I'll do this in purple. If you FOIL and pretty up x plus 2, x minus 2, you get x squared minus 4. Then all I need to do is give that to the x minus 3. FOILing that, x squared times x is x cubed. X squared times negative 3 is a negative 3x squared. Negative 4 times x is negative 4x. And negative 4 times negative 3 is positive 12. Double check that when you're done, you have a cubit because there are 3 roots. No like terms need to be combined, and that it's in descending order. That's all true, so I'm good to go. Number 2, my zeros are 3, that's x minus 3, 3, that's another x minus 3, and negative 3, that's x plus 3. So I'm actually going to start backwards this time. I'm going to copy this x minus 3 down, and I'm going to FOIL these two, because that's going to give me x squared minus 9. Remember, difference of squares FOILs into an x squared minus 9. So now I have to FOIL what's left. X times x squared is x cubed, and x times negative 9 is a negative 9x. Negative 3 times x squared is a negative 3x squared, and negative 3 times negative 9 is a positive 27. This is not in order. I actually need to switch these two so that they are in order. My final answer is x cubed minus 3x squared minus 9x plus 27. Cubic, 3 roots, all makes sense. All right, number 3, I have 4 roots now, so I better have a quartic when I'm done. My first 0 is x, or 0. That gives me a GCF of x out front. Just let that hang out there for a little bit. The positive 2 gives me a factor of x minus 2. The negative 2 gives me a factor of x plus 2. And the positive 1 gives me an x minus 1. All right, I'm actually going to let this x here and let the x minus 1 on the back. I'm going to work with these two first because they're opposites. They're going to give me x squared minus 4. Difference of squares. Now I'm going to FOIL these two and let this x out front. So x squared times x is x cubed. X squared times negative 1 is a negative x squared. Negative 4 times x is a negative 4x. And negative 4 times negative 1 is a positive 4. And now all I have to do is distribute the x out front. X times x cubed is x to the 4th. Good, we were expecting a quartic. X times negative x squared is negative x cubed. X times negative 4x is negative 4x squared. And x times 4 is 4x. All done. That's a quartic polynomial with the roots of 0, 2, negative 2, and 1. Pause the video to do the you try it. Today we found the zeros of polynomials, which are also called the x-intercepts of the function. We also use the zeros to write the polynomials in standard form.